9702 paper 1 variant 2 by June 2021. The topic is from the turning effect of force torque moment. Question number 13. A uniform square sine weight of 40 Newton is suspended vertically from its top edge by a horizontal hinge as shown. The hinge is not frictionless. When the sign is displaced from the vertical by an external force and then released, it doesn't return to its vertical position. So let let us discuss first these two statements. First of all, these two pictures a front is shown of a body of a signboard, front view and the side. So this is a front view like we usually see in front of the shop to view to the side passing the person who is walking on a footpath, and the shop is usually on the left. So this signboard gives a reflection of the board of the shop. So ये एक बोर्ड है जिसका जो कि साइड कॉर्नर में लगा होता है, तो इसका फ्रंट व्यू ये है, इसका साइड व्यू ये है. Acha, this supporting point is this hinge, right? So that means if अगर इसको हम इसे घुमाते हैं, if we move due to the weight, it must go down, right? ये नीचे चला जाएगा. But it is it is a friction. It is not a frictionless. That means the supporting point is the turning point the same is this hinge. इसका supporting point और इसका pivot point ये hinge है, right? और चूंकि ये friction मौजूद है, तो that means it is not movable. Okay, so a person whenever a person move this to the vertical or to the horizontal, उसको horizontal move करेंगे तो उसको वापस usually इसको इसी point पे आ जाना चाहिए. चूंकि ये frictionless नहीं है, it has a friction, that means it will not come back to its original position. So we need to understand this. हमें ये चीज समझनी है, right? This makes us this question easy, right? And one thing we need to check the equilibrium condition, that is the clockwise torque should be equal to the anti-clockwise torque, right? So if it is not the frictionless, that means we have two forces. One is the frictional force, and another is the weight of the object, right, of the board. So these two makes a turning effect, and if it is not moving, that means that two force turning effects are same. So the turning effect produced by the friction force is equal to the turning effect produced by the weight, right? So the next line, the maximum torque exerted by the hinge on the sign is 6 Newton meter. That means the turning effect due to the friction force is given, right? The sign displaced by 90 degree, so the horizontal and then gradually decrease. इसको 90 डिग्री में लाके छोड़ा, that is यहाँ पे, right? तो यहाँ पे लाके जब ये 90 डिग्री होगा, तो इसको जब छोड़ा तो ये वापस नीचे आएगा, लेकिन चूंकि हिंज फ्रिक्शन इसमें मौजूद है, it has a friction, so ये कहीं जाके रुक जाएगा. So let's say that this is the point when we move this board 90 degree horizontal and then release, it will come back to this position, and after that it didn't move, right? So that means from its original position it will make an angle which is theta, and the question is to find out that angle. So first thing first, we know the turning effect produced by the friction is equal to the turning effect produced by the weight. So it is given 6, straightforward 6. D is the half of the center of gravity is at the center. So if it is 8 meters, so the perpendicular distance is 4.4 meter. Now the tricky part is the weight is downward and it is the board is in this direction. So we need to resolve the weight into its component, horizontal and vertical. And according to the given condition, it is moving like this theta. So theta will be here. So if it is the theta is here, that means this will be the horizontal axis and this will be the vertical axis, and then vertical axis is making 90 degree to the displacement. So the turning effect that is responsible is W sine theta with this D, right? So this D, which is the half of the length, is 0.4, is point 0.8 is 0.4. So W sine theta and 6 and 0.4. So we after resolving we would get the theta which is approximately 22 डिग्री।